Let's begin with a very simple example of a limit cycle. And this first example is trivial algebraically, it's just pure rotation. So the equations of motion for this two-dimensional dynamical system are in polar coordinates, radial distance and the angle theta. And so suppose that my equations of motion are r dot is equal to r, 1 minus r squared, and theta dot is equal to 1. So in the theta direction, all that's happening is that there's constant rotation speed. And in the radial direction, it just looks like logistic growth, namely that r equals 0 will be an unstable fixed point and r equals 1 is a stable fixed point. So if I look at the trajectories in polar coordinates, here is x and here is y. So at r equals 1, there is a stable fixed point in the r direction. So that means that there's a circle of radius 1. And if we start with flow inside the circle, it's going to spiral outward because theta dot is positive, so theta is always increasing. So we start somewhere inside, we're going to flow to the stable cycle at r equals 1. If we start somewhere outside, we'll spiral inward until we hit the stable cycle. So this is a trivial example of a stable cycle.